Next, we are looking at the exercises under section 6.6 and we are looking at number 37. It says find the derivative of the function and also find the domains of the function and its derivative. Alright, so we're going to start by finding the derivative. So we have g of x equals inverse cos of 3 minus 2x. So the derivative is going to be minus 1 over, and then we have the square root of 1 minus 3 minus 2x squared, and then we still have to multiply by the derivative of the 3 minus 2x, which is just minus 2. So in other words, that means we have 2 over the square root of 1 minus 3 minus 2x squared. We are also asked to find the domains of the function and its derivative. Alright, so we are working with inverse cos. So we know that the domain of inverse cos is the same as the range of cos, which is from minus 1 to 1. So the domain of g is going to be all x such that 3 minus 2x is between minus 1 and 1, which means that it's all x such that minus 2x is between minus 4 and minus 2, and that is all x such that, so remember when we divide by a negative, the signs, the inequality signs are going to switch around. So we're going to have 2 greater than x, sorry, greater than or equal to 1. So we can write that as the values going from 1 up to 2, and it's the closed interval. We are also going to look at the domain of the inverse. For the inverse, the important thing to note is that our denominator cannot be 0. So that means whatever is inside of the square root cannot be 0. Another thing to note is that what is inside of the square root can also not be negative, because we can't take the square root of a negative value. So that means that the domain of the inverse is all x such that what is inside of the square root is greater than 0. Then I'm not going to do all of the steps, but you can isolate x so that you eventually get to the point where we have all x such that x is between 1 and 2. So it's the open interval from 1 to 2. The next problem is a problem from section 3.6 star, and it's on page 453, and it says differentiate the function where y equals e to the u minus e to the minus u over e to the u plus e to the minus u. Alright, so this here is a quotient, so we have to use our quotient rule. So the derivative is going to be the bottom multiplied by the derivative of the top. So the derivative of the top is going to be e to the u minus e to the minus u multiplied by minus 1. Then we have minus the top multiplied by the derivative of the bottom, which is e to the u, plus e to the minus u multiplied by minus 1, all over the bottom squared. Then we can simplify that a little bit. So if we multiply out our brackets, we are going to get e to the 2u, then we are going to get minus e to the 0, sorry, that's plus e to the 0, then we are going to get plus e to the 0 again, and then we multiply the last terms, we are going to get plus e to the minus 2u. Then we have minus, and we multiply out the second brackets. So then we have e to the 2u. Then I'm going to multiply the first with the second. So I have minus e to the 0. Then I have my second multiplied by my first, so it's minus e to the 0 again. And then I have my second multiplied by my second, so that's going to give me plus e to the minus 2u. And that's all over the bottom squared. So in the end, you'll see that all we have left over in our numerator is going to be 4 e to the 0. So these two are cancelling, and these two are also cancelling. So we have 4 e to the 0, and then in our denominator we have e to the u plus e to the minus u squared. So it means our final answer is just 4 over e to the u plus e to the minus u squared.